Well, one of the big topics in our linear regression unit is how to create the line of best fit and also making sense over what that line really makes. So as you guys know, in algebra, y is simply equal to mx plus b, where m is your slope and b is your y-intercept. And that works if you have 2 points, but what if we had a scatter plot like this over here on the right where you don't have 2 points, if you've got multiple points? Now obviously you could actually take a ruler and you could go ahead and maybe connect a line of best fit, maybe something about like this, but the question is, where does it go exactly? And so what happens is we've actually created some formulas to help us determine exactly where this line of best fit goes. So these are the formulas. First of all, the equation, instead of y, it's now y hat. That little guy up there is called a hat, and that means that we're going to be predicting what y is based on some other values. Also, rather than saying b is the y-intercept, in stats we say b sub 0 is our y-intercept and b sub 1 is our slope. So rather than slope being m like it is in algebra, it's b sub 1. And there's some equations for that. And one of them is the slope equals r times the standard deviation of your y's divided by the standard deviation of your x's. And also the y-intercept is the mean of the y's minus your slope times the mean of your x's. And the reason why is that x bar comma y bar, if that were an actual point, this point actually ends up being on your line of best fit. So let me show you how this would work here. So let's say we didn't have all the data points here and we couldn't enter in our calculator and run linear regression on it. Let's say instead we were given this scenario. What we have here is we have a number of cars, and we don't really know how many, but we do know this. The mean of the ages is 6 years old, the standard deviation is 2.88, and the mean of the y's, which is the price that is being offered for sale, is $6,800, and the standard deviation of those prices is 3,600. And we also know r is negative 0.94, which makes sense because as cars get older, the price should be going down as well. So how would you find the equation line of best fit for this? So here's what you would do. To find the y-intercept, what you would do is you would simply take r, multiply by the standard deviation of your y's, and divide by the standard deviation of your x's. So what is r in this case? Well, it's negative 0.94. The standard deviation of your y's is right here, 3,600. And then you divide by the standard deviation of your x's, which is 2.88. So you just grab your calculator, crank out the numbers here, and you wind up with a value of negative 1,175. And notice, by the way, that r is negative, and what do you notice about our slope? It's negative as well. So r and the slope should have the same signs. Now if we want to find the y-intercept, what we would do is we would take the mean of our y's, subtract the slope times the mean of our x's. So in this case, the mean of our y's is 6,800. It's minus, our slope is negative 1,175. And then times our mean of our x's, which is 6. So once again, grab the calculator, and by the way, this is the exact same thing as 6,800 plus 1,175 times 6. So when you grab your calculator, do the calculation here, you should get 13,850. Then what we want to do next is actually write out the equation. So we say y hat, because we're predicting y, equals our y-intercept is 13,850, and then it will be plus, I'm sorry, not plus, because what is our slope? Our slope is actually negative, excuse me there, so it should be minus 1,175 times x, where x is our age and y is our price. All right? So that's how you do it. You just use these two formulas here, and once you find the slope, you can use the slope here to find your y-intercept, including the means here. So it's really that simple if you're given these 5 values over here. And next, a couple other things here. We can use that to actually predict the price of a car. So for instance, if you remember, our equation was this: y hat equals 13,850, and it was minus 1,175 times x. But x is no longer x, this is x, because that's the age. So we're going to multiply it by 3. So what you would do then is you'd go ahead, you'd grab your calculator and punch in 13,850 minus 1175 times 3, and what you would wind up getting is 10,325. So that would be the cost, 10,325. The other thing you could do is you could do what's called find the residual. And so what it is this. The residual is this. If I were to go ahead and draw in, say my line of best fit here did something like this, where it started at some number and our slope was negative. We have points like here, which are down here. Anything that's below the line of best fit, our equation line, would be what we call a negative residual. And any points that are actually above it, so maybe up in here, would be what we call a positive residual. And the residual is this vertical distance between what the line predicts and what the actual is. So this is below, so it's a negative residual, whereas this point's above, so it's a positive residual. So here's what we know. There's an actual point in which it is 4 years old and it costs $9,500. So the idea here is we want to make a prediction now. So we want to make a prediction what if it was the exact same age? In other words, it was 4 years old. So what would our equation say? What we would do is we take 13,850, we would subtract 1175 times 4 to make our prediction. And so when we do that, we wind up with a value of 9,150. That's what y hat ends up being. I'm going to write over here y hat. So what happens is, this is a case where the predicted is some number and the actual is actually higher than it. So it's kind of like what's going on over here. This is the predicted down here, and this is what actually happens. So we want to compare the actual y versus the predicted y, and the residual is always the actual y minus the predicted y, okay, which is y hat. So in this case, the actual y was 9,500, excuse me there, and the predicted was 9,150, and so when you subtract them, you get 350. So our residual in this case would be 350. So those are some of the basics of how linear regression works in creating a line of best fit.